All right, let's do one more exercise. Let's do one more example of how latent heat works and also how you can be a savior at a party. So, here's how this one works. Have you ever been to a party before and gone outside and opened up a cooler hoping to find your favorite beer in there? And then when you open it up and you look for your favorite beer, it is not in there. And so you then have to walk around, you end up finding a case of it that's not cold, you pull one out and you think, man, I wish this beer was really cold. You stick it in the freezer, you have to wait 30 minutes, and, it's a pain in the arse. Well, I actually have a secret, a way that you can actually make a beer cold really, really fast using the magic of latent heat. So here's what I have going on. Right here, I have a bowl of icy, salty water. So it's basically ice, water, and salt. So I just use some water, some ice cubes, and then a generous amount of salt. You don't want to skimp on the salt on this. And what's going to happen is when you add salt to this briny, icy water, that actually lowers the melting point of the ice. That means the ice is going to melt quicker. It's going to melt sooner. It's going to melt faster. However, like with any latent heat exchange, in order for ice to melt, it has to suck in heat from its surroundings. Well, this beer from my favorite brewery called The Brewery is actually going to be those surroundings. So here's what I'm going to do. I'm going to take this, stick it in here. What's going to happen is over the next few minutes, as this ice is melting, give it a good stir. I can stir it a few times, but as this ice is melting, it's going to suck in heat from the beer can. And that's going to cool the beer down to a much more drinkable temperature very quickly. One thing I will say, I actually already did this using a can of bubbly a few minutes ago. And unfortunately, Camtasia didn't record the audio, so hence I'm doing it again. That's okay, now I get to do it with something else, and let's see how the results are. So initially when I actually put this can in here, the temperature of it was 68 degrees. That was room temperature. So the temperature was 68 degrees, which was room temperature. Let's see what it is in a few minutes when I actually mix it up. And this can actually work really quickly. At this point, the ice has already melted quite a bit, so I'm not going to see the effects as quickly. But if you have pretty much all ice and just a little bit of water and a lot of salt, you can actually see results in a matter of just a minute or two. So this one's going to take a little bit longer just because some of the ice has already melted, and so a lot of that latent heat exchange has already happened. But there's still plenty of ice in here. Still plenty of heat to be sucked up. So still plenty of example to show. So I'm sure you may have already heard about this, doing this in a party setting. You may have also heard about something that I strongly recommend against doing called the Salt and Ice Challenge, where you take an ice cube, you put some salt on it, and then you put it over your arm. You'll get frostbite doing that, so don't do that. And if you do that, don't sue me. But that's something that's been spread around over the internet. But basically what's happening here right now is, as I mentioned, the salt actually lowers the melting point of the ice. So the melting point of the ice is usually 32 degrees. Well, salt causes it to melt at a lower temperature. So this is allowing the ice to melt at a lower temperature. Because of this, the ice melts quicker. It doesn't have to heat up to 32 degrees to melt. Instead, it melts much, much quicker. As it melts quicker, as I mentioned, it has to take in heat from its surroundings. That whole latent heat thing still applies. And right now, this can of Mima's famous Sticky Bun Stout is the surroundings. So a lot of heat is being sucked up out of this can into this ice as it's melting. After a few minutes, this beer is going to be a lot colder. So it's a good idea to stir it around just a little bit, just to kind of get that ice onto it. Like I said, this is actually the second attempt I've done of this tonight. So the first one was flawless. I just forgot to record the audio. So, bloopers ahoy! Awkward silence. Yeah, this is how it feels like sometimes. That's okay. In a moment, I'm going to pull it out, and we'll see what the temperature is. We'll see if it's actually cooled down substantially. So its initial temperature was 68 degrees. What will its temperature be when I pull it out? Alright, let's do it. So, it's definitely a bit cooler to the touch. It's not cold yet. Like I said, this would work better if I hadn't let the ice melt as much as it did. But it's still pretty cool to the touch. I can wipe it dry to get any ice and water remaining off of it. And now, using that same infrared thermometer I used earlier, let's see what the temperature is. The temperature of it is 51.6. That's actually a pretty good serving temperature for a stout. So that's actually perfectly cold for a beer like this. But if you wanted to cool it for even longer, have it in there for longer. Or, like I said, the other thing that you can do is you can actually have more ice. Some of the ice had already melted. Alright, so that's it for this example. I hope you all enjoyed this, and hopefully you become a hero at the next party you go to. Cheers!